Have you ever wondered a little bit more about the fundamental theorem of algebra and what it means to factor a polynomial into all linear factors? Well, stay tuned. Welcome to Planet Numeracy. This is Mark Nolde, your personal math coach. So today I'm going to show you 3 examples about how to complete the factorization of any polynomial. So stay tuned till the end. There's a few blind spots that I have to let you know about, and we'll catch you on the flip side. All right, so let me show a quick example here. We already know that when we have a third degree polynomial, that means we're going to have 3 zeros. So whatever the highest degree the polynomial is, that's how many zeros there will be. But it's not just real zeros, it also includes complex zeros and multiplicities. So here's an example that will show you multiple zeros that are complex. So the first thing I would do if I were going to solve this is I would set it equal to 0. And I notice that I have, an x minus 3 and an x minus 3. So I'm going to factor this by grouping. This works out kind of nicely here. So I'm going to factor by grouping. Let me do this. And I'm going to factor, this first part, x squared comes out of that. Because notice I have an x squared common to this term. So x times x squared is x cubed. And x squared times minus 3 was the minus 3x. So over here, I still have an x minus 3. But here's a common, sometimes people get slipped up on. It's easy to have a blind spot to this. How many of these are there here? Because I'm going to factor this out, and what's going to be remaining is the x squared and however many of these there are. So the correct answer is there's one of those. So I'm going to put a 1 right in front of that. So then I'm going to factor out an x minus 3. That's my common factor. And what's left over is x squared and the plus 1. Still equal to 0. But now I can say, zero product property. If this times that equals 0, then either this is 0 or that is 0. So if the first one is 0, easy enough. X is 3. If the second one is 0, that means x squared is going to be a negative 1. Hey, that's the imaginary unit. When I take the square root of both sides, let's do that, square root of both sides. When I take the square root of both sides, I get x equals plus or minus the square root of negative 1, which remember is our imaginary unit. And we use a lowercase I for that. So now I have my 3 zeros. I have x equals 3, x equals plus or minus I. So 1, 2, 3. Now the other thing that we can do is we can write this as a product of linear factors now. So this is the other part of the factor theorem. That when you combine it with the fundamental theorem of algebra, means we can do this. So these are all linear factors. So I have a minus, a negative I. So that would usually get simplified. If you check down an answer key or back of the textbook, something like that, you're going to have these 3 linear factors. Now, the nice thing about having linear factors is they also tell you the solutions. 3, x equals 3, and this became this. So we get plus or minus I. All right. So here's an example that's going to illustrate the multiplicities. So we're looking at a 4th degree polynomial here, p of x to the 4th plus 4x squared. So there should be 4 zeros with this according to the fundamental theorem of algebra. So what happens on a problem like this, when we set it equal to 0, we factor. So I have a common factor of, that's an ugly x squared, common factor of x squared. So I'm going to factor that from this expression. So notice we have x squared plus 4. So if this times that is 0, either this is 0 or that is 0. But there's a multiplicity of 2 here because it's a square. So I could say right off the get, x equals 0. And let's see, x squared plus 4 equals 0, making x squared equal to negative 4. So we're going to have x is equal to plus or minus 2i. So that takes care of our zeros up here. The next thing we need to find are our factors, all the factors, factor completely. Well, I guess in stepping this out, I would technically be looking at x minus 0 2 times because of multiplicity 2. And let me just jot that down here. Multiplicity 2. So there's my 1, 2, 1, 2, 3, 4. So we have our 4 zeros. So now we're just going to write out 4 linear factors in the process. So x minus 2i, x minus negative 2i, right? If we're keeping with our program here. So this just ends up becoming an x squared, and this would simplify as x minus 2i and x plus 2i. Right? That's because we have minus a negative. That's going to become a positive. So here are linear factors, 4 linear factors of this 4th degree polynomial. So that's kind of an interesting thing. All right, so this one is interesting. X squared plus 25. Going to show a real quick trick here. Ordinarily, let's suppose this was x squared minus 25. Then I would be able to factor it as either x plus 5 and x minus 5. Supposing I had set the whole thing equal to 0. Or I could have said x squared equals 25. Take the square root of both sides. Square root. And I'd have plus or minus 5. So what we need to do is kind of make it into a minus. So in looking at this, I could do one of two things. I could see it as a minus, a negative 25, and then look to factor it. Well, the square root of negative 25 is going to be 5i. So I'd have x minus 5i and x plus 5i. So there's just another technique that we want to share, because they won't always look so nice as this one, which is just x squared plus 25 equals 0. Ordinarily, in this case, I would do this, but I wanted to show you with one that was easy to do what would happen. So we still get the correct answers, the correct zeros, plus or minus 5i. So let's move on to another one that makes it a little bit more interesting. Right, here's another one. Looks a lot like two different squares, right? This is a perfect square and this is a perfect square. So they are two different perfect squares. However, I'm adding them. I'm not subtracting them. Could I turn that into a subtraction problem? Because if I don't, here's what we have to do. 4x squared, if this was equal to 0, we'd be looking at 4x equals negative 9, 4x squared equals negative 9, x squared equals negative 9/4, and then taking the square root of both sides, I'm now taking the square root of a negative number, and a lot of times that confuses us into going, oh geez, is it plus or minus 3i or 3 halves I? We're not really sure. But if you can look at this over here originally as a subtraction problem, it kind of eliminates this guessing game over here. So let me do 2x plus what's the square root of negative 9? Plus or minus 3i. So 2x plus 3i times 2x minus 3i. Now it becomes kind of clear that you're looking at a plus or minus 3 halves I. If this times that is equal to 0, either this is 0 or that is 0. So let's make this equal to 0 first. And let's see, 2x plus, nope, not plus, 2x equals negative 3i, dividing both sides by 2, we get negative 3 halves I. So that's what this would have been over here, a plus or minus 3 halves I. But until we get comfortable dealing with fractions, sometimes setting it up this way helps students see it a little bit easier. So this is just a little trick. It may help you, or you may prefer to do it, I don't want to say the old-fashioned way, but finishing this off, if 2x minus 3i equals 0, then x would be 3 halves I. Then, if you wanted to write out the factors, what would you have to do? Well, I'd have x minus negative 3 halves I and x plus, well, let me write minus minus. I already wrote minus minus. So just make this a minus 3 halves I. And if I simplified that, I'd have x plus 3 halves I and x minus 3 halves I. So you might be wondering, what is the difference between this and this? Well, they're equivalent expressions. They both are equal to this, the original polynomial, but notice that these are both linear coefficients. Linear, linear. So this is also linear, but this is what they're looking for when they want the linear factors, because this is solvable. This gives us our solutions. So that wasn't so bad. So what big questions do you still have about complete factorization? Let me know down in the comments below. Remember, there's no such thing as a dumb question. It's dumb not to ask. Don't forget, math is not a spectator sport. You have to do math to learn math. So take advantage, go out of your comfort zone when you're doing those tough problems on your homework assignments. In the meantime, please go ahead, hit the like button, subscribe, comment down below, and I will catch you in the next one.